Okay, what? Oh,
All right, here we go.
Yeah.
Okay, we're trying to explain to you our rationale for providing this course. So I'm Dr. Kiddo.
I'm Dr. James Brownlow.
And we're both adjunct instructors here at the Antelope Valley College, but we both worked, or at least I worked at Edwards Air Force Base and have retired, and Dr. J continues to work there. We were statisticians analyzing the data collected for flight tests for the Air Force. We both taught at the Flight Test Center because we found that our engineers were not knowledgeable about statistics and yet really had to do it to make sense out of what they're doing, and as such we taught using a variety of programs. We've had Statistica and JUMP and SPSS and Design Expert and Minitab, so we have some experience with a variety of different software programs, but eventually started using R, mainly because it was free and very, very expandable and seemingly used by all of the graduate universities, at least teaching universities, that we found throughout the country. So we're here to explain why you want to take this course that we've developed and the history behind how it got there. Let me try something here. All right. So the goal we have here is to create a course that teaches students how to create reproducible research products, answering questions, research questions, based on data that comes from experimental or observational studies, using the common techniques like chi-squared test or t-test or regression, the simple processes one learns in an introductory statistics class. If we do it right, we think that we can create an individual capable of doing that in a one-semester course. In a second semester, we could potentially cover all the material in, say, the statistical sleuth textbook used to teach statistical consulting in many different universities, and we use that book out at the Flight Test Center as a basis for our work out there. I guess unlike calculus or linear algebra, what is happening in statistics now is going through a major upheaval since the development and use of computer methodology, machine learning and whatnot. You're almost forced to use a computer to do the task. And we've also noticed that all the courses taught, at least in community college level, go back to what you would be doing in 1950, 1960. You have a book, you look things up in tables, and it's really not that pertinent anymore. And we need to change that if we're going to have people capable of working in this modern world.
We have to meet the needs of our students is really what it boils down to, and it's our responsibility to educate students in a way that they can apply statistical methods to current day problems using techniques and computers. I mean, today we have problems involving large data. We have techniques that were not available, or might have been available, but were unable to do things like resampling techniques, Monte Carlo. The ideas were understood, but the implementation and the computer power just wasn't there. Well, today it is. And so now statistics has evolved to those using those techniques. And along those lines, let's talk a little bit about the history of the course that we have developed here at Antelope Valley College.
Well, okay, we started off, both of us got together and said we need to teach the students how to use probably R because it's free and it's very capable, and let's see. So we started teaching how to use R.
First courses we did, we just used R by itself. So here's a statistical technique, here's how you do it in R, and so students were forced to learn the statistics and learn the intricacies of R at the same time.
And we kept telling ourselves there's got to be a better way to do this. Somebody probably already has a course that does this. We ought to look around and see if we can find it instead of continually trying to invent our own wheel. Well, as we moved along, we continually learn too. If you're not learning, then you're going backwards. That's how it works today. So we both took a course from Stanford by Hasty and Shiversani on machine learning, and in there learned about our studio and what our markdown files were, and thought, well, that is the way to go. We got to start doing that. So that was the beginning of changing the way we teach this course. And along the path kept saying, there's got to be somebody that probably has already done this. Let's continue to look. And lo and behold, we found Homer White at Georgetown College in Kentucky. And he had already created the course that we were trying to create. So, doing the sensible thing, we called him up and said, Homer, can we use your material? And he gladly said yes, and gave us all the material. And part of that material was a test bank that was built into a program called Moodle. Well, neither of us have ever heard of Moodle before. Well, it turns out what Moodle is this really very powerful course management system. Now we had all the questions that went along with Homer's course in Moodle, so we had to get Moodle to see what we had there. So we went along a path of finding a local guy here that runs Moodle in the Antelope Valley Union High School District. So we got onto his Moodle server, put the course in there, and saw what we had, started using it there, and then it became pretty apparent that we had to learn Moodle, and we also had to get our own Moodle site, because there are things you do that only administrator of Moodle can do, and we had to have those set up the way that Homer needed them set up for the course, and so we ended up getting a Moodle site. Fairly inexpensive, and we talk about it in the material on this website where you can get the Moodle load for the course.
So the key there is one has to learn a little bit about Moodle and how to be an administrator in that, and it is not that hard. Also, there's a lot of help available for using Moodle. So we've integrated our course into a Moodle site, our entire course.
Right. So along with the question bank that we got from Homer, we had to get Moodle, and we found that Moodle is cheap. You can buy your own Moodle site, which is what we did, and integrated this material into Moodle. And then, keeping our nose to the grindstone, looking on the internet, we find that right now very popular is courses that you pay for to learn data sciences. So let's see what those guys are doing.
See what that's about.
Got to see what everybody's doing if you want to keep up with the crowd. And in doing so, we also learned about Git and GitHub and how important they are in this process. And so now we have instituted those in this particular course, adding to it. And I think one other innovation about the course that we saw is that you can't just have a course depending on, let's say, Jump or Minitab or something that's installed on the computers in your institution. Because think of what you're doing. You're teaching your students how to use some software that they will not have once they leave your institution. Well, we said, we don't want to do that. We want to teach them something that they can carry with them. And so we worked and found out that we can make all this stuff executable from a USB stick. So we put it all on a USB device, and there's some tricks you have to do in order to do that, but they're all doable. So now we have the Moodle site that we own, and what we give the students is a USB stick that has all the software on it. The software is R in RStudio, and a portable version of Git, and a portable version of Python, and a a portable version so they can create PDF files, all executable from this USB device, which makes it very nice because they learn how to use the tools, and then they have their $10 USB stick, and they take that down to UCLA or up to Berkeley or to Stanford or something, and can continue to use it that way. All you do is you stick the thing in your Windows-based machine, the scripts that run it are on the USB stick, you click on it, and away you are, sort of an independent. For $10, you have a complete statistical toolkit that you carry with you anywhere you go.
And I should point out that includes ancillary materials, additional textbooks, videos, source problems, reference URLs for additional help. And the nice thing about it is we've gone through the process of setting the whole thing up for a USB. So what the student does is simply goes to our Moodle site and gets into the class, in the Moodle class, and then the first week there's a link. You just click on download material for the USB, and then extract that. It's a zip file. Extract that, and then everything is on the USB and is executable, and we're up and ready to go. No additional textbooks to buy. Nothing else that has to be done. The only requirement is, of course, the educational institution has to have PCs available for students that are internet connected.
Or else, I suppose, you would require them to bring a laptop or something, but I would still recommend you put it on the USB stick, because trying to deal with a variety of operating systems and stuff is going to give you a big headache, whereas we kind of got this working pretty well. Again, let's see. So what is it that you would have to know in order to teach this course? Well, first, you pretty well have to know R. And so if you know R, you've got a leg up on being able to teach the course. Although you're going to learn a few new things, you may not be familiar with everything our studio does, but you can learn that as you go along through the course. And you're going to have to learn a few other things that both of us weren't familiar with until we heard about them and then did our homework by reading after midnight into the text on what Git was all about. So you're going to have to learn what Git is, but it's available, and there's a nice book. It's called Git in a month of lunches, and if you go through that book, you'll pretty well learn how to use Git. Well, we actually incorporate that in our course. If you download the course and look at the second bank of instruction in the course, it's all about Git and GitHub and how this stuff works with built-in exercises and workshops that Moodle calls it, to get the student up to speed on that.
So we're basically getting the students to the point where they are able to use R Studio, which has a very nice GUI type interface, and then also Git and GitHub. Git allows them to do version control on projects. They have daily assignments and then project assignments. And then GitHub allows collaboration on projects. They can share a project, they can download from other places. So those are skills that are essential for current day statistical operations, actually.
And so, again, what we're trying to do is give them the full Monty, or whatever you want to call it, the complete list of tools necessary, including R and RStudio, understanding of what Git and GitHub and how you collaborate with Git and with GitHub, and then how to produce coherent statistical reports that take data and analyze it. And we use some interesting data. Last semester, Dr. J here gave problems from the General Social Survey from 2014. I think this time we may be looking at what Nate Silver is doing to predict the current election, the methods of resampling that he imposes, and we're also doing a whole bunch of resampling stuff since we have a computer, and that's the hot way to do things, to expand the student's thought process on what's going on here with statistics, and give them the tools to do it. That's our goal.
Well, also the resampling, I think, facilitates understanding a lot better than just reading the name of a test and then implementing it. So,
So that's basically the idea. If you know, we're giving this away, but you need to know that if you don't understand R, you're going to have to learn that probably before you attempt to teach this course. But I think that's doable, and there's usually somebody around that knows it. If you already are a person, say, like us, that maybe recently retired or working as an adjunct, in the
Should
second
retire.
then you'll be able to easily pick up this course. If not, if you're someone new, just got hired at a community college just out of school, well, you got some learning that you'll have to do because you probably don't know these things. But if you go ahead and install this course and sit through it one time, take it yourself before you try to teach it, I think you can work your way along. If you're in that process, I would suggest you get a group of you to work through it as a group, because you can answer each other questions. And we find that our students can answer their questions when we force them to work in groups, and that works quite nicely. So that's kind of where we're going with this thing, and we'll continue to put on this GitHub repo what our current load is. But since this GitHub repo has all the other stuff we'll put on it, if you clone this thing, you can go back and see that several other Moodle loads are loaded in here. And so if you're familiar with Git, you can go back and go on the branch and get whichever one you want out of there to see what we were doing in the past. All makes the use of Git much more interesting, and how that all works.
And the key basically is this. We've packaged the statistics course into one place, the entire course. So you've got a Moodle setup that you can download that implements the entire course. And when I say entire course, I mean it includes all of the software that's needed, includes ancillary materials, supplementary materials, the problems, the questions, the assignments, and all of this is within Moodle. And once you download that, of course, you being the administrator of the Moodle can then set that up any way that you see appropriate. But it's all there in one place. So the requirements are students have to have access to a PC and the internet so they can download the material, and then have to be able to use Moodle, and that's where the assignments are taken, and also assignments are turned in through Moodle. And then it's easy for us to grade using Moodle, and there's some automated grading features in Moodle as well. The only key, I think, is for an instructor is, as Dr. Kiddo was saying, yeah, you've got to learn how to use R. If you've never seen it before, it may seem a little bit intimidating at first, but RStudio is a GUI implementation. It's fairly direct. It has add-ins that make things very nice, and it's fairly easy to use. R Markdown and R Notebook are now parts of it. They make developing code phenomenally easy, and then Git is integrated into RStudio as well, so it makes the Git version control very easy as well.
And then there's one nice shout out to Homer White, who developed this very fancy thing called plot add-ins that use the RStudio add-ins capability. It's very nice. It makes using the graphics package called
ggplot2, yeah.
No, it's Mosaic Graphics.
Oh, Mosaic, yeah.
And it's point and click. You can make extremely fancy plots with very little training using that package. And there's a bit in the course where Homer's actually showing you how to do this, but it'll take your students to a very high level of graphics presentation capability in a very, very rapid fashion.
Yeah, it's very easy to learn.
You're going to like that part.
Yeah,
very
2
well.
minutes.
Yeah.
And they're making great graphs.
Okay,
well, anything else, Bill?
I think the other material that you're going to see in here in the form of these videos will explain the maintenance required. You basically have to keep recreating the load file as R comes out with new capability. We always make a new load file probably every six months or so,
yeah.
and you will too. So
Or just go get ours.
yeah, but probably you'll want your own if you change direction.
Yeah.
To add some other packages to your R that you have them download, because I think we have about 200 packages in ours, and you may take a different approach.
Yeah, you may have different applications,
Yeah.
economics, biology, sociology, psychology, more directing toward those areas. Well, you pick up the packages for those things.
But it's a good way to go, and it gives your students something that they can use for the rest of their career until something better comes along, but they won't be shut out because they left your institution where you taught them SAS or something,
And then they
don't
don't
have it
Yeah,
anymore.
Yeah.
So those are key things we paid attention to in the building of this course, and we wanted to make sure that that was explained. All right,
Okay.
I think that's it.
Well, thank you for listening.
Okay.